very warm welcome to all of you students. Last class we have completed up to applications of concave lenses and application of convex lenses, and some of the ray diagrams also we have discussed. I hope you are all understood. Further, today let me discuss about a lens formula, sign conventions to be followed in lens formula, a magnification of your lens, and some other topics also here we are going to discuss. Already I told you three important factors we must consider that we know already, which is focal length, object distance, image distance. Focal length is denoted by the symbol small letter f. We have to be very careful in that we must use small letter f only. Capital F, it stands for focus point. And object distance, which is denoted by the symbol u. Image distance, which is denoted by the symbol v. By relating these three important factors, we have lens formula. Let me pass on to the topic. Like spherical mirrors, we have lens formula for spherical lenses too. Already we have discussed about spherical lenses. The lens formula gives the relationship among distance of the object, that is small letter u, distance of the image, that is small letter v, and the focal length f of the lens. It is expressed in terms of 1 by f is equal to 1 by v minus 1 by u, or what showing in the screen, that is also correct. 1 by v minus 1 by u is equal to 1 by f. So this is the formula for the lens. It is applicable to both convex and concave lenses. But we need to give on utmost care while solving numerical problems. What should be care? Related to lenses in taking proper signs of different quantities. Related to lenses in sense, we have a concave and convex lenses type. According to the type, different quantities should be considered by the sign, which is it may be positive or negative. Accordingly, we have to substitute. That is, we have to be proper sign of different quantities. That is, sign conventions. What are the sign conventions to be followed? Sign convention is nothing but which is whether positive or negative. How we are taking positive or negative, based on which concept, that is only sign convention. Cartesian sign convention are used for measuring the various distances in the ray diagrams of spherical lenses. According to the Cartesian sign convention, we have to follow some points to be followed very strictly. What are the points? Let me discuss. Look at the diagram carefully, student. What is the first point? It says the object is always placed on the left side of the lens. Where to place the object? Object to be placed on the left side of the lens. And I'm going to show you in many diagram. We can compare. So what is second point here? I told you object must be placed. First point is object must be placed left side of the lens. And what is the second point? It says all the distance are measured from the optical center of the lens. We know well what is the optical center, which is O, which is middle of the lens. They are represented O, which is optical center. Actually, we have to measure the distance from the optical center. And what is the third point? The distance is measured in the same directions as that of incident light are taken as positive. So here they have given direction of incident light. So if the distance is measured in the same direction as that of incident light are taken as positive. The distance measured against the direction of the incident light are taken as negative. So here they have given the sign also, that negative sign, which mean what is that? The distance measured against the direction of incident light are taken as negative. The distances measured upward. The distances measured upward. We have to take it as positive. So the distance measured upward, we have to take it as positive. Listen here. Height upward they have given, which should be in positive. And here also we can notice it, but here they didn't give. Listen here. Come to the right hand side. A dash and B dash, which is the image. The distance they have measured, not the distance, the height they have measured below the principal axis, so that it should be taken as negative. Once again, the distance measured upward and perpendicular to the principal axis is taken as positive. The distance measured downward and perpendicular to the principal axis is taken as negative. I hope you all understood, students. These are the rules to be followed. These are the rules followed while writing sign convention, which I told you already. Depends upon the position of the object and the position of the image, that sign will be different. So you have to be careful while writing that. Let me pass on to the next topic, which is a magnification of a lens. Definitely, you must have experience playing with the magical lens. Magical lens already I think you know. So when you playing with the magical lens, when you keep lens closer to the object, the size of the image becomes bigger, as like shown in the picture. When you move the lens, magical lens closer to the object, the size of the image becomes big. When you move object away from the lens, or else when you move a lens away from the object, the size of the image becomes small, as you know already, which is applicable. Magnification is applicable for both convex and concave lenses. So I think you are very clear. So when you move the object very closer to the lens, so what happened? What is the size of the image? And here also, when you move closer to the lens, here in sense for the concave lens also magnification is applicable. So here also we can notice the difference, that is size of the object and size of the image difference, we can notice it. So magnification is nothing but how many times the image of an object is magnified with respect to the object size. Have you understood, students? Magnification is nothing but how many times the image of an object is magnified with respect to the object size, which is how much is big and how much is small when compared to the object. So this what magnification. Like spherical mirrors, we have magnification for spherical lenses too. Already you have studied in the lower classes about spherical mirrors. Spherical lenses produces magnification, and it is defined as the ratio of the height of the image to the height of an object. We have two formula for the magnification. One is depends upon the height we have. Magnification is denoted by the small letter m. If the height of the object we can take it in which manner, h1, and height of the image we can take it as h2, or else we can take it as hi for the height of the image and ho for the height of the object. And then based on the distance also we can measure the magnification, which is magnification is equal to distance of the image divided by distance of the object. So already we are very well about the image distance and the object distance. Image distance we can take it as v, small letter v, and object distance we can take it as small letter u. So the formula becomes m is equal to v by u. If the magnification is greater than 1, then we get an enlarged image. Have you understood, students? If the magnification is greater than 1, actually when you substitute the values in the formula, once if we get the answer greater than 1, then we get an enlarged image. On the other hand, if the magnification is less than 1, then we get a diminished image. Listen the magnification equation, students. M is equal to hi divided by ho is equal to, we can take it as distance by v by u, but here they have given di by do, whatever it may be, but it means distance to the image and distance to the object. So you have to be very clear in that. So listen here. Here also they have given in the terms of v by u, and here they have given h and h dash. H dash is denoted for the image distance, and h is defined for the object distance. You have to be very clear in that. So listen the formula carefully. M is equal to h dash divided by h is equal to minus v divided by u. That is minus symbol, which is nothing but a negative sign in the value of the magnification, indicates that the image is real. A positive sign in the value of magnification indicates that the image is virtual. Are you clear, students? Next, let me pass on to the next topic, which is a lens maker's formula. Look at the picture, students. The formula which is shown in the picture is lens maker's formula. All lenses are made up of transparent materials. Any optically transparent material will have a refractive index that is denoted in the symbol n, but we can take it as mu also. The lens formula relates the focal length of a lens with the distance of object and image. For a maker of any lens, knowledge of radii of curvature of the lens is required. This clearly indicates the need for an equation relating the radii of curvature of the lens, the refractive index of the given material of the lens, and the required focal length of the lens. The lens maker's formula is one such equation is given as 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. Have you understood, students? R1 and R2 already we have discussed very long before, which is radius of curvature. And let me pass on to the next topic, which is power of a lens. What it says, power of a lens. When a ray of light falls on a lens, the ability to converge or diverge. Convex lens will be converge and concave lens will divert the light rays. Depends on the focal length of the lens. That is, converge or diverging the light rays depends on the focal length of the lens. This ability of a lens to converge, that is for convex lens, or diverge for concave lens, is called as its power. Hence, the power of a lens can be defined as the degree of convergence or divergence of light rays. Power of a lens is numerically defined as the reciprocal of its focal length, that is P is equal to 1 by F. The SI unit of power of a lens is diopter. It is represented by the symbol capital D. If focal length is expressed in meter, then the power of a lens is expressed in diopter. Thus, 1 diopter is the power of a lens whose focal length is 1 meter. By convention, the power of a convex lens is taken as positive, whereas the power of a concave lens is taken as negative. Next, we will discuss about the difference between convex lens and a concave lens. A convex lens is thicker in the middle than at edges. A concave lens is thinner in the middle than at edges. It is a converging lens. It is a concave lens is a diverging lens. Convex lens produces mostly real images. Concave lens produces mostly virtual images. Convex lens is used to treat hypermetropia. Concave lens is used to treat myopia. I hope all are understood. Thank you, students.